Good morning, everyone. Today, as I announced on the Microsoft Teams group, students have the chance to ask questions, and I try to revise the different course contents that we covered during the semester. I think the first question that arrived was from Balhis about the rolling horizon planning. So let's start with this question. It was here. Wait, I share this with the full screen, and not only the slides. So Balachis asked about the slides number 11, which covered the advanced planning in supply chains. And I guess her questions were motivated by two questions from the quiz. Please, Balachis, if you want to add something, let me know. So let's go to the advanced planning in supply chains. And here we have the rolling horizon planning. So maybe before I go into the details of the rolling horizon planning, a more general message about learning. Believe it or not, the first step in learning, or first major step in learning, is really to identify, to understand what you do not know. So often a student might be overconfident and thinks he or she knows already everything, and therefore there's no inner motivation to really start the learning. The other extreme is that a student is somehow lost in all the materials that were covered and does not really have an overview of what has been discussed and just has a bad feeling, oh, I don't understand anything. Yeah, then you first need to reach a level that you have an overview of the different materials and can classify the different materials, the different topics. You know which topics are discussed. Maybe you do not yet know the specifics of the individual topics, but you have an overview what has been discussed, and where you, with this overview, then you can create an idea where you can look for additional information. So when I asked you yesterday to present questions that you want to discuss, I forced you to think about these different areas and the open problems that need to be discussed. Yeah? So you already made one additional step to better master the topics. Now a quick summary of the rolling horizon planning. Well, you as a manager need to get some idea what you want to do in the future, what your company, what your department needs to do in the future. And one approach, particularly related to production planning, is the rolling horizon planning. So maybe you decide how much you want to produce in the next year. You break it down on a monthly basis. What will be the output, the production, the manufacturing output for every month in the next calendar year? Which types of products do you want to produce in which months? And this decision will depend on the forecast you have. Now, we all know that the future is uncertain, and as soon as you start planning and implement the plan, things will change. This does not mean that we do not need planning. By doing the planning, we are much better prepared to deal with possible changes in the future. And in the rolling horizon approach, we plan a couple of periods in the future, what we expect to happen, what we want to do. And then after the first period is over, we look what did actually happen in the first period and how does this impact the other periods that we already planned. So in this example on the slides, the plan is for 12 months. We start with an initial plan for 12 months. Then once at the end of January, we know what has actually happened in January, and we create a new plan for the next 12 months based on the information, based on the actions that happened in January, and we plan the next 12 months. Once the second period, February, is almost over, we do the same. We now know exactly what has happened in January to February, and based on this information, we again update our plan and create a new plan for the next 12 months. This is the main idea. And now I will answer the questions from Balkis. So I guess, make it a little bit bigger. Yes. Come on. So now we have here some statements, 3 statements, and we need to decide if the statements are true or false. So the first statement, a rolling horizon plan is executed without planning updates. The keyword here is without planning updates. No, that's not true, because that's exactly the point of the rolling horizon planning. We have sequential updates of the plan. The length of the planning horizon in a rolling horizon approach is usually constant. Yes, that's also right. So we always plan, in the example from the slide, we always plan for 12 months. But keep in mind, there's no rule that the rolling horizon plan needs to be always 12 months. It could be also for the next 16 weeks, for example, if we plan on a weekly basis. For you as a student, you might plan ahead for the next 4 semesters, what courses you want to take. You could plan even your whole study program for the next 8 semesters when you start in semester 1. And your plan will include which are the courses that you want to take in which semester. And let's say after the first semester, you realize I passed every course of the first semester. Okay, probably there will not be a need for many changes. However, if you, for example, failed in logistics management, or you failed in mathematics or financial accounting, then you need to revise and update your plan, because you have to repeat one of the failed courses. And if you cannot go for over credits, then you need to maybe extend your study period or change the courses that you want to study in which semester. So now the last statement. A rolling horizon plan is always created for 12 months and updated at the end of each month. So this is the example that we shared in the slides. One way to do it, but as I just said, there's no rule that this is always on a monthly basis. There's no rule that it's always on a yearly basis. So this is just a concept, an idea how to plan, and it's not fixed that it needs to be on a 12 months planning horizon. Okay. Is there, shall I add something? think it's fine, right?
No, not complete.
Yeah. Let's move on to the next one. So the first statement, a rolling horizon plan ignores the event of the last period for a plan revision. So why is the statement false? So the statement is wrong, the way it's phrased here. So why is it wrong? What do you think, Valeries?
It's wrong because we have to see like the records of the past months.
Yes.
Then we make the planning for the other months.
Yes. So you actually want to see what has happened in the first planning period here in January, and based on this, you continue with your plan. You update your plan. You don't ignore what has happened in January. The statement basically says you ignore what has happened in January and continue. This is not true. We want to see what has happened in January, and based on this information, we update the plan. Yeah.
We see just the records of the last month of the period.
Okay, basically, you look what has, in general, you look what has happened in the past. Yeah? So when you are in the first months during January, and at the end of when you plan for on a monthly pattern, yeah? So you update your plan every month, and then now you are in January, and update your plan before the start of February. Then you're mostly interested in what has actually happened in January. Then, when February is over, you are interested in what has happened in February. But of course, your previous plan was already based on the things that happened in January. Yeah? So this is just, you're always interested in what actually happened in the past, but this is not a new information for your plan. Yeah? So when you are planning, for example, here in the third level, starting March, you already based your previous plans on what has happened in January. So therefore, it's not new information for your planning. Does this answer your question? Did you get my point?
Yes, I got it.
Okay, good. Maybe also you got these statements here correct, but maybe still say a word or two on this. A rolling horizon plan is updated once a planning period ends. Yes, that's exactly what we're doing. We have monthly planning periods, and once the first month is over, we start to update our plan. If we are on a weekly planning horizon and we plan for example, 16 weeks, then after the first week, we would update our plan. If you plan your geotech studies and you are on a semester-based planning period, you would update your plan after each semester. Once you know the outcomes of the courses, if you have passed or if you have failed, and also what might be offered. This is also something the logic of the semester planning as a geotech student. On the one hand, you need to take into account what has been passed, which course have to pass, which course needs to be repeated. On the other hand, you need to take into account, for example, what life skill or elective courses are actually available to you, and you will not know this 3 years ahead. This is only announced immediately before the start of the semester. Yes, and now the third statement makes this generalization. We plan for 8 weeks. The planning period is a 2-week cycle, bi-weekly cycle. So therefore, we update the plans after week 2, 4, 6, 8, etc. Yeah. This is exactly correct. Okay, that's it about the rolling horizon planning. Now, I'm not sure, but where you also mentioned the slide number 9 in the same slide set.
Yes.
Yes.
I want you to explain them like briefly again, the
Yes.
difference between them.
Okay, so when we are talking about an advanced planning approach, an advanced planning system, we have 3 special properties that we also want to, that make why we call this planning system advanced, in contrast to, let's say, regular standard planning systems. So, first of all, we have a more integrated planning approach. That means, let's say we are a company in a supply chain, and in traditional planning, we would look at our own situation, at our own, for example, sales planning or production planning. Now, when we say we integrate our planning approach in the supply chain, it means we also take into account the plans of at least our customers and our own suppliers, our tier 1 suppliers. We can take into account our tier 2, tier 3 suppliers as well, or the customer of our customer. So that's even more integrated then, but at least we should have a look at our suppliers and our customers. And we negotiate with them, we plan with them together. What are their capacities? Are they planning to open a new factory? Did something happen to their factories that limits their output? The same for our customers. So we try to bring together several organizational units that plan together the activities in the supply chain. So this is one point, integrated planning. The second point, which is here highlighted as true optimization, means that we use more sophisticated, more advanced methods of planning. And we are not just using rules of thumb in the discussion with our suppliers. We use more advanced mathematical tools, mathematical methodology to create plans. And some of these optimization problems have been introduced on a very, let's say, on a very beginner level in this course. You will have more courses, particularly advanced operations research, advanced operations research, modeling language in the coming semesters, where you talk more about these concepts. But I gave you in this course a first overview about how to create mathematical models. Particularly, you saw this for the transportation problem, and you saw this right in the beginning in week 2 or 3 of the course, where we introduced this, what was the name of the model? The model to decide if we should accept a customer request or not. And I showed you what are the components of such a model. We have the objective function, we have the constraints, we use software. Here in this course, we use Excel to solve these problems. There are more advanced softwares out there, of course. So we really come up with a model that helps us to make the decision. And let's say in traditional planning, the contrast is that people sit together in a meeting without proper decision support tools, and they just, let's say, have a discussion without proper models. So therefore we say an advanced planning system is using true optimization approaches. Okay, and the third factor that comes together when we are talking about an advanced planning system is that there is a hierarchy of the planning tasks. So there are some planning tasks that come first and other planning tasks that come after this. So typically we first make a plan for the forecast of our future sales, and then we decide how much we should produce, as a simple example. You see this hierarchy, I think, yes, here it's directly on the next slide. We have the long-term planning tasks in the highest level, in the most upper level. These planning problems, we try to solve them first. And based on the outcome of these problems, we try to solve the midterm planning problems. And again, based on the outcomes of the midterm planning problems, we try to solve the short-term planning problems. And there's always a feedback, so therefore these arrows are in both directions, from top to bottom. And so there's always a feedback from the lower level to the upper levels. So we don't ignore what's going on the lower level, but let's say the driver of the whole process starts from the long-term planning tasks to the midterm planning tasks to short-term planning tasks. And this is the hierarchy. This is the hierarchy. So in particular, it's not possible. It would be great if we could do this, but at the moment, the technology, the mathematical knowledge, the computers are simply not able to plan all the tasks simultaneously. This is really a technical limitation at the moment, a mathematical and computational limitation. We are simply not able to plan all these tasks together. On the other hand, because we have the feedback from the lower level to the upper level, which might trigger a replanning, and we also do not do a pure sequential planning. So again, I try to give you a geotech-related problem in planning. So we need to come up with a schedule for the next semester. What does this include to create a schedule, a teaching schedule for the next semester? First, I need to know, or one ingredient to the schedule is I need to know which professor will teach which course. This is one of the first decisions I need to make. This then includes professors that are working as permanent staff at geotech on the one hand, and fly-in, drive-in professors on the other hand. Another decision is at which time will I offer a lecture of one course. This might sound like a simple problem, but it is not, because in order to decide this, I need to know which rooms are available. Maybe there are other departments that want to use this room. Of course, a professor can only have one lecture at a time. This sounds simple, but it can have a lot of complications. I need to know if the lecture is purely on campus or if it's somehow mixed online, offline. And I need to see which rooms are available. In particular, in our department, we have the challenge that we have many lectures with a lot of students, and therefore we need a lot of big rooms. But we do not have so many big rooms available at all the time, because engineering also wants to use them. So I cannot have everything on campus. under the COVID restrictions at least. So you see, I have a lot of decisions, and the ideal outcome would be if I can have a mathematical model that makes all these decisions for me at the same time, simultaneously. But typically this is not possible because there are too many things involved. Yeah? So our methods are simply not powerful to do this at the moment. So we break down this problem and decide first which professors can offer which courses. Then we decide which are the available rooms, and we try to assign professors to time slots in rooms. And then we see how does the plan look like. Oh, there are many inconvenient things happening. For example, a student batch has a class from 8 to 10, and then from 4 to 6. That's not a good plan. And then we try to fix these things by giving this information back to the higher level. So we are also using a hierarchical planning approach. In sequential planning, you would not revise previous decisions. You would not revise previous decisions on a higher hierarchy. You just would create the long-term plan once, give the information to the midterm planning problems, create the midterm plans, and then use this information to create the short-term plans. There's no feedback to the upper levels. And when all these three characteristics are present together, then we speak of advanced planning systems. Okay. Any questions about these advanced planning issues? I didn't get you, but it's fine?
Yes, it's fine. It's
Okay.
clear now. And Mr. I have another question.
Yeah.
In the final exam, are you going to bring article type questions? Like you give us an article and we answer the questions that's related to it?
Yeah, like what we did with the Financial Times article, where you read about a real world problem, and then you were supposed to answer this. Yes, this might be a question type that is coming in the final exam.
What do you think is the best way for us to prepare this kind of questions?
It depends a little bit where your challenges are, but in general, I would say just regular reading of advanced business news will be very helpful. So it's not about reading only the existing Financial Times articles, and I will bring one of the existing articles that are already uploaded on Moodle. This is not a good approach to prepare for these types of questions. I want to encourage you to read more about general business news related to supply chains, that you can just process this information from real world events on your own and for yourself. So reading 1 or 2 articles every day, short articles every day, is, I think, a very good way to prepare for this type of exercise.
Also, Mr. Why there is no time for the final exam? Like we just have 1 day and a half in between our other exam, because I know you prepare the dates and stuff, right? Or
the schedule for the final exam is created by RSA. Though I'm not creating the schedule, the professors are not telling RSA on which day which exam needs to be. This is scheduled by RSA. So therefore, I cannot specifically answer your question. On the other hand, you know, if the final exam weeks, we have 2 weeks of final exams mainly, so 10 days on which a final exam can happen, and you have typically around 5 or 6 courses that you are enrolled to. So if you need to spread 5 exams on 10 days, you cannot really create a plan with a lot of gap between the final exams. You have 10 days that you can choose, and you need to pick 5 days for exams. So it's not really possible to, for example, have always 3 days between exams. And on the other hand, as a more general recommendation or a general remark, you know, when you start preparing for a final exam, this should not start 1 day or 2 days before. You already know this, of course, yeah, but I feel I always need to emphasize this. So the real learning, good learning, needs to happen during the semester already, from week to week. And then maybe on the last day, you can have a quick recap. But if you push everything to the last minute, maybe you can be even successful in terms of passing the course or getting a grade that is okay, but you don't really learn it. Yeah, you just forget everything after the final exam, and on the short term you are very happy that you passed the exam, maybe with a good grade, but long term it's not really helpful for your scientific career or your academic career, and you will not really learn how to apply the knowledge from the courses to real world problems. Okay, so I mean, if there's a problem in the schedule, in particular when there's, for example, a conflict between exams, this might happen if you have to repeat a course, please always contact RSA about this. And then they can try to find a solution. You mentioned that the final exam week is basically 3 weeks instead of 2 weeks.
No, it's 2 weeks.
Yeah, I mean, some courses, maybe some German courses or some blocked courses for other students might be earlier, but the main problem is we have 10 days, maybe a little bit more, to place the exams, and then there's not much room between the exams. Maybe what should not happen, though, if this would happen to one of you, you should not have 2 assessments with a weight of more than 30% on the same day. Yeah, on the same day, not on 2 different days, but on the same day. So if you have 2 assessments, for example, when you also have to repeat an exam, you should contact RSA about this. Yeah? This is in our regulations, that a student should not have 2 assessments of more than 30% per day. Okay. More? Anything else?
No, you can complete.
Okay. There was another question on Microsoft Teams regarding the transportation problem. Come on. Here was a request by Mana for the using the Excel solver for the transportation problem. Here, I think this is maybe the only restriction in the final exam, and I wrote this in my announcement. Highlighted here again. Yeah. Using Excel, like in quiz 4, will not be necessary. Yeah, so, but he's asked about the newspaper articles. Something like this might come in the final exam, but I will not ask you to set up an Excel model of the transportation problem or another problem. But I mean, keep in mind, this does not mean, I'm not saying the transportation problem or anything related to Excel will not be part of the final exam. Yeah? I mean, you saw the questions in quiz 4, where we, for example, presented a screenshot, and you need to understand and interpret the numbers on screenshot. Something like this can be part of the final exam. Yeah? So don't ignore these topics. And I also recommend that you use Excel when you prepare for the final exam, that you use Excel, change the numbers, play around with the numbers, set it up yourself, use the solver, interpret the numbers to see what's going on, when is the solution feasible, infeasible, etc. But I will not ask you to do this in the final exam. But still you need to understand what's going on and how we can solve the transportation problem. Maybe I jump to the introduction of the transportation problem. And in terms of preparing and learning, I think I said this several times, and sorry if I repeat myself, using the textbook and reading what's going on in addition to the slides is really, really helpful. This improves your reading skills and your self-learning skills dramatically, and this will be very beneficial for your whole study life and for your future life. So always use the textbook. Okay, maybe it's not the right slide set. So the first thing was that you need to make sure that the Excel solver is really installed, because by default it is not installed. Yeah, you go to the data tab in Excel and click on the solver. Maybe even if you take one more step back, you know that you can access Microsoft Excel with your GeoTech account. Using the GeoTech account gives you the right to use Excel. You can use Excel on the web, and you can also download it and install it on your laptop. This is highly recommended for every student in a business-related domain. Excel is one of the main tools you will work with. Now, once the solver is then really installed, if you cannot find it, there are several YouTube videos. I think I linked one YouTube video in Moodle. If you type in load the solver add-in in Excel into the help file, which you can access by pressing the F1 key, you will also find a small summary how this is done. And then the next point, you can also download this Excel file from Moodle. This is now important to understand what are the decision variables, what are parameters that go into the Excel file, and what is the meaning of these coefficients of the objective function. What is the meaning of the decision variables? How is the objective function calculated? Yeah, we multiply the value in the gray cell of column B with the value in row 7 of column B. So we multiply these two, add them together with the next column, add them together with the next column, etc. That's basically the objective function of our transportation problem. You need to understand this matrix, which reflects the connections between the factories and the warehouses, if it's possible to transport something. And here you have then the outgoing or incoming loads in a factory or a warehouse. And here on the right side in the dark blue column, you have the given parameters that reflect the capacities. And in order that the solution is feasible, every value in the gray cell needs to be equal to the value of the blue cell. If they are unequal, the standard transportation problem will not be feasible. And then in our tutorial that was presented by Nama, we discussed a couple of extensions where we can adjust the model to a little bit more realistic settings. And this can then also be reflected on the level of Microsoft Excel. And many changes can either be reflected in changing the input data or changing the way the model is solved by changing these equality constraints to inequality constraints. This can particularly happen when the demand from the warehouses is not equal to the supply of the factories. But what I will not ask of you in the final exam to set up this table yourself and solve it. This is not what I will ask of you. But maybe if I present such a screenshot, such a outcome, you need to be able to understand what's going on and what is what. Okay.
Mr. If Excel was not able to solve the problem, that means that the solution is infeasible?
Okay, assuming you set everything up in the correct way. This is, let's say,
Yes.
as a beginner, this is already a big step to set up everything in the correct way. So if our formulas and everything are right, the setting of the solver is right, it can happen that we are not able to find a feasible solution. So we get a kind of error message. It's not able to fulfill the demand on both sides, for example. And then this will be reflected that we don't get a feasible solution, though this can happen. For example, if I stay with this model that is shown here, that supply and demand has to be equal, I can simply construct a situation where the demand is higher than the supply of goods, and then I never can fulfill some of the equality constraints. And then it can become unequal. So my recommendation to get a better feeling what's going on here is to start with a feasible solution that you know when I solve it with Excel, it is feasible, and then play a little bit around with the numbers, with the supply, with the demand, with the cost values, solve it again with the setup you know that is working, and see what is the outcome, what are the error messages. This is a way to really understand what's going on and learn a lot. Okay, so I answered all the questions that were posted in Microsoft Teams. Now from my side, I'm done with my additional input. The question is now, what shall we do tomorrow? Because if there are no more questions, it's no need to ask the students to come to the classroom. Shall we have another online session tomorrow if there are more questions, or shall we just cancel it, or shall we just meet regularly in the classroom and discuss any upcoming questions? What are your suggestions?
If they ask anything in Teams, we will have a class like online session, but if there were no messages, then it's cancelled.
I mean, we can do it in a similar way like we do it right now. If there are more questions, ask on Teams, just like yesterday. We can discuss them in the same way we are discussing them now in an online session, which is recorded. But what you need to be clear about, we can do this for tomorrow, but not like then every day new questions are coming up. Then the semester is somehow over, and okay, you can drop by in one of my office hours, but I cannot offer now support for a lot of students that did not come today because they have other things to do. And then when they start asking questions in 1.5 weeks, and that's the timing is then not very good, and it's also a little bit unfair because now we have a public session with public information for all the students, and I cannot give let's say individual tutorials to individual students who cannot join these sessions that are open for everyone. So okay, then I suggest I call again for questions via Microsoft Teams, and then we can have another Zoom meeting tomorrow with the regular class timing from 12, starting 12 p.m. and discuss more questions in the same way we discussed them today. Okay, is this okay with you?
Yes. Mr. Also, are you going to bring, like, when we have one mistake in the questions, the other answers will be also wrong, like we lose marks just for one mistake?
It depends on the number of questions, but typically what I did for some questions, there were 3 statements, and you need to have all 3 correct, because when there are 3, I want to avoid that students are able to just randomly check and guess some answers. But if we had in the quizzes other types of questions with, let's say, 10 statements, then I will give you partial points. So if there are a lot of statements in one question, I will not activate this rule that everything needs to be correct.
Okay, Mr. If you are going to bring it, don't bring so many like this type of questions, so we don't lose more.
I try to keep it balanced. But then the main point is to not guess the answers or make it more difficult. You know, there are some students who really can confidently answer the question, and others, they, okay, what I also did, when I didn't know, I just guessed something. But then if it's, you know, if you can pass an exam by just guessing the answers, then that's not good, and it's a very big disadvantage for those students who really understand the concepts. And there's not enough difference between the students who are well prepared and know their stuff, and those who are not so well prepared and have to rely on chance too much. So there will be some of these questions, but I try to keep it balanced. Okay. Yeah, and maybe let's say how to prepare for another way to prepare for the questions is, of course, looking at the style of the quizzes. This is usually always helpful to look at the tutorial classes, the previous quizzes, because the final exam will at least be in a similar way. It will not ask for completely different types of questions. But on the other hand, this is a big but, don't just memorize the existing questions. I might make new questions, change the existing questions to confuse you, use different numbers and these things. And then if you have only memorized the answers of previous questions, this is not, this can help you somehow pass the exam, but for your life, for your later life, it will not be beneficial at all. It will not help you in understanding the topics. So look at the previous questions, but don't rely on them too much for your learning. Maybe also one final remark for today. I guess Quality Assurance finally shared the links for the course evaluation. I got some mixed messages from colleagues. For some, the evaluation was already active. For others, it was not active. Then there were some technical problems. So I'm not sure what is going on for our course, but maybe you can have a quick...
We received the emails.
Okay. So maybe you can start giving some feedback on the course. Remember, we discussed the feedback of the previous batch at the beginning in the first week of the course, and there can be some valuable comments from the students in terms what could be improved, what was a very big challenge. So this is something that we look at. Also, I also try to explain to you, we cannot follow every suggestion for different reasons. Yeah, sometimes it's more the opinion of an individual student. Sometimes this will be covered in a different course or whatever. But we try to get some idea how the course was with you, of course. So if this link is now working, just give a quick feedback on the things. Okay, guys. Then, if more questions come up, please post them on Teams, and we will have an online session tomorrow as well. Okay?
Okay.
See you all.
See you.